Good afternoon to one and all. I am Kalyani, Assistant Professor, PG Department Mathematics, Vellore College for Women. I know the topic is binomial distributions. In that random variable, the mathematical rule are the functions that assign a given numerical value to each possible outcome of experiment in the sample space of interest. In a random variable, there is a two random variables. First one is discrete random variables. Second one, continuous random variable. Simply, the random variable is one of a perfect example is when you are tossing a coin, there is only two outcomes. One will be the success, another will be fail. If you are tossing a coin, the outcome will be head or tail. Same that the binomial distribution is introduced by Bernoulli's. Under that Bernoulli's constructions introduce that, so that we have to give the random variables as Bernoulli's random variable. Imagine a simple trial with two possible outcomes. One is success, another one is failure. Success will be simply denoted as a capital S and failure is denoted as capital F. The example is some of the examples are here. The few examples only I given. First one is toss of a coin. That when you toss of a coin, only the two outcomes head or tails. Head will be represented as a capital H and tail we represent as capital T. And the second one, sex of your newborns, that is one or male or another will be the female. Another example is survival of organism in a region, that is live or die. Another more example is throwing a dice, the outcome will be 1, 2, 3, 4, 5, 6. Out of 6, the only one outcome will be the given. That is the next one, the binomial distribution overview. Suppose we have to consider the probability of success is P, and then what is the probability of failure? That is, if P is success means failure will be considered as 1 minus P, because in binomial distribution failure plus success always will be equal to 1. That is P plus Q equal to 1. That's why we given that probability of failure will be equal to Q equal to 1 minus P. That is, failure will be equal to 1 minus success. That is the probability of failure. For previously, say that some example, that is tossing a coin and throwing a dice or something else. For this example, what is the success and what is the failure? Let me see that if you tossing a coin, S is a head, that is the outcome will be considered as a head means P equal to S equal to head, that is outcome will be S means the probability of success will be denoted as small p, that value is 0.5. How it becomes means, that is when you toss a coin, outcome will be head, but the choice of outcome will be head or tail. For head or tail means that is two options, head or tail, but the success will be the only one, that is only it becomes head or tail, therefore outcome will be 1, so that the success will be P, that is small p will be equal to 1 by 2, that is we say that 0.5. If you find the success as 0.5 mean, by using a success value, simply we calculate the failure probability value, that is Q, that will be equal to 1 minus P. Already we say that Q equal to 1 minus P. That P is success, so that 1 minus success will be equal to, that is 1 minus 0.5. Same that failure also, probability of failure will be also 0.5. If you, this is examples for tossing a coin. If it head comes, it will be the success will be 0.5, failure will be 0.5. If it tail comes also means the success and failure will also the 0.5. Another one example, when you roll your dice. Already I say that when you roll your dice, the outcome will be 6. If you consider as an outcome as 1 means, out of 6 outcomes, we have only 1, that is 1 will be displayed only one time. Therefore, 1 by 6 is the success probability, that is P equal to 0.16667. Next, failure is nothing that 1 minus success. So Q equal to 1 minus P, that is 1 minus 0.1667 is nothing that 0.833. Next, one more example, fertility of a chicken egg. That is X will be equal to fertility means the probability will be success of probability will be small p equal to 0.8. Success is 0.8 means failure is 1.0.8, that is Q equal to 0.2. Next, imagine it should be repeated as of one more time or 5 times or 3 times or 25 times. That is in the last example also, when we toss a single coin means the outcome will be head or tail. If you toss a coin as a 5 times or n times the output will be different. That is, imagine that the trail is repeated in n times. Example first one, a coin is tossed as a 5 times. Up the choice will be the 5 coins will be the header. Otherwise, 5 coins will be the tail, or head tail or repeatedly it becomes for 5 times. Next one is that die is rolled as 25 times and 50 chicken eggs are examined. In this example, we have to assume the P remains constant from trial to trial and that the trials are statistically independent of each other. That is, one output come is when we toss the 2 coins mean first coin is head, second coin tail means the outcome is different. Next, from previous example, they say that what is the probability of obtaining X success in the n trials? Examples, what is the probability of obtaining 2 heads from a coin that was tossing 5 times? That is, for probability of tossing a 5 coins mean the possibility should be possibility of first coin's head, second coin head and 3 more coins, the outcome will be tail means probability of H T T equal to 1 by 2 of 5. That is the value of 1 divided by 32. There is some possibility. If you count 5 coin tossed mean first 2 coins head, remaining tail. Another possibility should be first one head, tail, tail. Another way is tail, head, tail. Same that some possibilities will be there. If 2 heads becomes mean the probability of 2 heads will be equal to 10 into 1 by 2, that is 10 by 32. Next, in general, if trials is result in a series of success and failures, that is 2 times failure, next success, again failures, this time of failure success becomes means the probability of X success in this order means P of X equal to failure, success. Same that success mean P, failure mean Q. Our probability will be Q, P, Q, etc. That is P times of that simple example formula is P power X into Q power N minus X. However, if order is not important, then the P of X equal to N factorial divided by X factorial into X N minus X factorial, P power X into Q power N minus X. Where P is nothing but success, Q is nothing but failure. Where N factorial divided by X factorial, N minus X factorial is the number of ways to obtain the X successes in N trials. This is an example of 1, that is probability of 0.1, 1.5. This is the overview. Another accepted value of random variables exam formula, that is A of X will be equal to summation over I equal to 1 to N, AI into Pi, that will be equal to I value varies from 1 to N. So we have to substitute I as a 1, A1 P1 plus A2 P2 plus etc. up to AN Pn. Next is variance should be sigma square of X will be equal to expected value of X minus expected X whole power square. That value is summation I equal to 1 to N Pi into AI minus summation I equal to 1 to N AI Pi the whole square. This is a closed interval 0, 1. We have to consider the value of up to 0 to 10. We consider as a f of x value 1 by 10, otherwise 0. Otherwise means if the value increase from 10 that means 1, the probability value should be 0. That is closed unit interval which contain all members between 0 to 1, including the two hinge points 0 and 1. An expected value e of x equal to integral x into f of x dx. That formula is b plus a divided by 2, and sigma square of x is b minus a whole square divided by 2. Thank you.